Strategies for working with data as it grows. Hello everyone, my name is Marco Carranza. I'm an entrepreneur and also the technical co-founder of Teamcore Solutions. I have been a user of Python for more than 15 years, and I have had the opportunity to use it extensively to develop many technological solutions for the retail industry on a global scale. In Teamcore Solutions, we process sales information through machine learning algorithms, giving companies visibility into the execution of their products at each store, generating insights and specific actions for the office and the field teams. The objective of this talk is to view alternatives for processing data using different types of technologies and data frames. First, we will take a look to different techniques to keep Pandas memory usage under control and to allow us to process larger files. Then we will take a look in how we can vertical scale our Pandas loads using Jupyter notebooks. Next, we will learn about this amazing Python library, Vaex, so we can process a large amount of data that cannot fit in our memory. Then we will try Modin, so we can speed up our Pandas code with a minimal change in our Python source code. And finally, we will take a look to Pyspark and understand in which cases it's a great alternative. Introduction. Nowadays, data is getting bigger and bigger, making it almost impossible to process it in regular desktop machines. To solve this problem, during the last years, a lot of new technologies have emerged to process all the data using multiple clusters of computers. The challenge is that you will need to build your own solution on top of these technologies, requiring designing data processing pipelines and in some cases, combining multiple technologies. However, in some cases, we don't have enough time or resources to learn to use and set up a full infrastructure to run a couple of experiments. Maybe you are a researcher with very limited resources or a startup with a tight schedule to launch a product to the market. Usually, the software that processes data works fine when it's tested with a small sample file. But when you load the real data, the program crashes. In some cases, some simple optimization could help to process the data, but when the data is much larger than the memory available, the problem is harder to solve. In this talk, we will show you multiple strategies to process data locally and review some alternative tools that could help us to process large data sets using a distributed environment. Pandas is the de facto tool when we are working with data on Python environments. Now we're going to see a couple of tricks that will help us to control the memory of our workloads in a better way. Trick number one, sparse data structures. Sometimes we have data sets that came with many empty values. Usually these empty values are represented as NaN values, and using a sparse column representation could help us to save some memory. In Pandas, sparse objects uses much less memory, especially if we save these objects as pickle on disk, and when we are using them inside a Python interpreter. Let's take a quick look to a small example. As we can see in this data frame, when we list the content of the column name Education 2003 revision, we'll see that there are a lot of rows with NaN values. And then if we take a deeper look to how much memory we are using, we realize that we are consuming a lot of memory, something close to 19 megabytes. So with a very simple command, we can change the data type of that column and tell Pandas to use a sparse type object. So after doing that, if we take a look again to the memory usage, we'll see that it has been reduced a lot. So basically, after changing only the data type, we have reduced the memory in 41%. This maybe doesn't look too much, but it's very useful, especially when you have very large data sets that comes with a lot of empty values. Trick number two, sampling. Sampling is a very interesting and useful technique and will help us to create a smaller data set from a larger one. And if it's done in the right way, will help us to run a faster analysis without sacrificing the quality of the results. Pandas has a special function for that named sample, and let's see an example. In this example, we have one large data frame, so we are creating a sample of 1,000 rows. But before running a sample, you need to be careful, because a common mistake is that a lot of people think that if they only pick up the first 1,000 rows, will be a right sample. But in reality, the correct way is to use this function, because you will get a more uniform sample that is better for further analysis. For example, if we run later the function describe pandas, we'll get some histograms and also some descriptive statistics. And if you can see, if we compare the result of the original data frame with the sample one, the results are pretty similar. Also, if we take a look to the histograms, we'll see that both are very similar. But if we make the mistake of only picking the first n rows, you will get a completely different result. Okay, trick number 3, load only the columns that you need. In some cases, we have very large data sets that comes with many columns. In some cases, you can have hundreds of columns. So there's no point to load all these columns into memory. So the basic rule is less columns, less memory. So let's take a quick look to an example. In this small example, we have a large text file that is 3.8 gigabytes on disk. So basically, after reading it, we realize that we have 77 columns. And if we analyze the memory usage, we will realize that we're using 4.5 gigabytes of memory. So a quick way to reduce the memory usage is only to select the columns that we are going to work with. So after selecting these 4 columns that you can see in the example, we realize that we have reduced the memory from 4.5 gigabytes to a little bit more of 300 megabytes. Also, this could be done directly when reading the CSV file. Number 4, use smaller numerical data types. There are like multiple data types in Pandas, and according to the type, we can store more or less information. For example, if we want to store the age of a person, there's no point of using the data type int64 because we are going to waste a lot of memory. In that case, it's much better to use a smaller data type as int8. Let's take a quick look to an example. For example, in this data frame, we can see the column name detail age type, and we realize that all the values are between 1 and 9. But when we analyze the data type of that specific column, we realize that we are using int64. So the recommendation is to change that data type, and we realize that we are using 196 megabytes of memory, but after changing it to a smaller data type, we will be using only 24 megabytes. That means that we could be reducing with only one line 87.5% of the memory consumption. Trick number 5, using categorical data types. In some cases, it's possible to shrink non-numerical data and reduce the total memory footprint. For these cases, Pandas has a custom categorical data type. So let's take a quick look to an example. In this example, we can see that there's a column named sex that could have only 2 categorical values, F and M. So when we analyze the type of data that we're using, is an object. If you remember, the objects can consume a lot of memory. So when we look deeply, we realize that we are using more than 142 megabytes of memory only for that column. But then if we change the data type as a categorical type, we will see a huge memory reduction. We will reduce from 142 megabytes to only 2.4. That means that we are reducing the total memory to 98%. Trick number 6, reading data by chunks. Attempting to read a large file can lead to a crash if there's not enough memory for the entire file to be read at once. Reading the file in chunks makes it possible to access a very large files by reading one part of the file at a time. Let's take a look to a small example. In this example, we have a very large file that is almost 4 gigabytes on disk. So basically what we are doing in Pandas, we are reading the CSV file, but we are adding a parameter named chunk size. So in this case, we are iterating over the file and reading the rows in blocks of 500,000. So every time we read a part of the CSV file, we'll start to apply and count all the values, and then all the results are being stored in a different variable. So after looping, every time we continue looping, we will release the memory and read the next chunk. So after finishing all the process, we will get a result with the desired calculation. Vertical scaling with Jupyter on the cloud. The easiest solution to not having enough RAM is to throw money to the problem. That's basically vertical scaling. Thanks to cloud computing, this is a very easy task. Vertical scaling is the ability to increase the capacity of existing hardware or software by adding resources, CPU, memory, disk, etc. On the other hand, we have horizontal scaling that involves adding machines to the pool of existing resources. Jupyter is a very popular tool that helps us to create documents with live code. Thanks to this tool, it's very easy to run this code on the cloud, and there are plenty of large and cheap machines all around the cloud providers. What is the advantage of this approach? Basically, no code change is needed. It's very easy if you are using the right cloud tools. There are like plenty of options like Binder, Kaggle kernels, Google Colab, Azure notebooks, etc. It's very good for testing and cleaning data and visualizing it. And the good thing is that you only pay for what you use. Of course, if you forget to turn off your machine, you will have to pay that too. And which are the disadvantages of this approach? Is that in the long run, it's very expensive because you haven't really optimized your code. You're only throwing more money to the problem. It does not scale very well, and also it's not production ready. Normally your code is not optimized for production. Speeding up Pandas with Modin. Modin is a multi-process data frame library with an identical API to Pandas. That means that you don't need to change your code because the syntax is the same. Modin will allow users to speed up their Pandas workflows because it will unlock all the cores of your machine. Also, it's very easy to install and only requires to change a single line of code. You have to change panda import to import modin.pandas as pd. So it's very easy. Pandas implementation is single-threaded, so this means that only one of your CPU cores can be utilized at any given point of time. But if you use Modin implementation, you will be able to use all the available cores of your machine, or maybe all the cores available in the entire cluster. The main advantage of Modin is that unlocks all the CPU power of your machine. Only one import is needed, so no changes in the code are needed, and it's really fast when reading data. Also has multiple compute engines available to distribute the calculation on clusters. These clusters could be implemented with Dask or Ray. And the main disadvantages of Modin is that you need to expend extra effort depending on the compute engine setup Dask array, plus the configuration of the clusters. Also, distributed systems are complex, so debugging could be a little bit tricky. And finally, Modin requires a lot of memory, also as Pandas. Processing large datasets with Vaex. Vaex is a Python library with a similar syntax to Pandas that help us work with large datasets in machines with limited resources where the only limitation is the size of a hard drive. Vaex provides memory mapping, so it will never touch or copy the data to memory unless it's explicitly requested. Vaex also provides some cool features like virtual columns and can calculate statistics such as mean, sum, count, standard deviation with a blazing speed of up to billion object rows per second. For the best performance, Vaex recommends using the HDF5 format. HDF5 is able to store a large amount of numerical dataset with their metadata. But what do I do if my data is on a CSV format? No problem, Vaex includes the functionality to read a large CSV file by chunks and convert them to HDF files on the fly. To do this is very easy. We only need to add the parameter convert equals true to the function from CSV. Also, Vaex provides a data frame server, so calculation and aggregation could run on a different computer. Vaex provides a Python API with WebSockets and a REST API to communicate with a Vaex data frame server. The advantages of Vaex are it helps control the memory usage with the memory mapping, and also there are amazing examples in their website. Also, Vaex allows computing on the fly with a lazy and virtual columns. It's possible and easy to build visualization with a dataset larger than memory. Machine learning is also available through the Vaex.ml package, and data can be exported to Pandas data frame if you need a feature that is only available on Pandas. Also, the disadvantages of Vaex are you need to do some modifications to your code, but the syntax is slightly similar to Pandas. Also, Vaex is not as mature as Pandas, but is improving every day. And also, it's a little bit tricky to work with some of the data types with HDF5. All in with Pyspark. When you need to work with a very large scale data, it's mandatory to distribute both the data and the computation to a cluster. This cannot be achieved with Pandas. Spark is an analytic engine used for large scale data processing. It lets you spread both data and computation over clusters to achieve a substantial performance increase. Pyspark is a Python API for Spark. It combines the simplicity of Python with the high performance of Spark. Also provides the Pyspark shell for interactively analyzing your data in a distributed environment. Pyspark supports most of Spark's features, such as Spark SQL, data frames, streaming, machine learning libraries, and Spark Core. So the advantages of Pyspark are: first, you will get a great speed with a large dataset. Also, it's a very rich and mature ecosystem with a lot of libraries for machine learning, feature extractions, and data transformation. Also, Spark runs on top of Hadoop, so it can access other tools in the Hadoop ecosystem. In the other hand, we have some disadvantages. For example, the first thing that you will notice is that you need to modify your source code because the syntax of Pyspark is very different to Pandas syntaxes. Also, Pyspark could have a very bad performance if the data set is very small. In that case, it's much better to keep using Pandas. In Spark, we have the machine learning library, but at this moment, it have fewer algorithms. Also, Spark requires a huge amount of memory to process all the data. So in some cases, this could not be very cost effective. Final notes. There are multiple options to scale up your workloads. The easiest way is to vertical scale your resources with Jupyter and a cloud provider. But first, don't forget to optimize your data frame or you will be wasting money. Also, there are some powerful alternatives to work with large datasets like Vaex, so it's worth giving it a try. If you need to process a huge amount of data, you can use Modin with Ray or Dask to distribute your workload, but this will add some extra complexity. Finally, you can rewrite your Pandas logic to make it run over Spark data frames and take advantage of many platforms available in almost all the cloud providers. Thank you very much for your attention.